Welcome back, Patriots. This is Mr. Love, aka the Math Patriot, bringing you another fun and exciting class in the world of high school geometry. To my local class, I apologize for not being there today. My son got sick and I had to stay home with him today. So this is the best we could do instead of you guys just sitting there staring at the wall like I know you ought to rather be doing. Actually, it's not the wall. Y'all be staring at TikTok or Snapchat or something like that, but we are going to be doing actual math today. So also your notes that you have in front of you are going to look a little bit different than normal. It's really just going to be a copy of what I have here. So write on it as we go through. And again, I apologize for that. Best I could do at the last minute. So we're going to be covering starting a new unit today about transformations. You've covered this before. We're talking about reflections, translations, dilations, and rotations, just like you did back in middle school. We're just going to go into a little bit more in depth, and we're going to talk about some of the nuts and bolts that actually make these things work. The first thing you need to know, and I'm going to use a translation as an example here, and just for simplicity, I'm going to use a circle. If I'm going to translate a circle, translate means just to slide it somewhere across the plane. So I'm just going to move it over, and then it's going to be the exact same circle right there. Now, the original circle that I drew, that one we're going to call the pre-image. And then the circle after the transformation is going to be called the image. Okay, so just a little bit of vocabulary before we get into the next couple pages. The original is called the pre-image, and the transformed shape is going to be the image. So, starting off with reflections. First off, a reflection is a flip of a figure. Now, notice this word here. It says flip of a figure in a line. Personally, I don't like that, but that's the way that's written in just about all the literature. Okay, so it's reflection in a line. When I say in a line, basically I'm saying that we're reflecting it over line L. So if this guy over here is my pre-image, I'm reflecting it over L, and that's where I get my image over here on the right. So each point of the pre-image and its corresponding point are the same distance from the line, which means that if I was to measure this distance would exactly equal that distance on every single one of those points. Also, if a point is not on the reflection, then the reflection is on the perpendicular, the reflection line is the perpendicular bisector of the segment connecting them. Here's what I mean by that. If I was to make this line segment between those two, then the line of reflection, line L, is going to be perpendicular to that. And since we already said that they were equal, then line L is a bisector. Basically, line L is a perpendicular bisector of the one connecting those 2 points. And it will be the same for each pair of corresponding points. And if the point is on the line of reflection, then it's the image and the pre-image are going to be the same point. Now, that makes perfect sense, because if I was to put a point right here, how in the world can I reflect that? Well, it's got to just stay on the line. So here's what we mean by that. Also, the corresponding point in the image is always going to have this apostrophe here. We pronounce that A prime. When you get to calculus, you'll start seeing some double prime and triple prime things, but anything in math with an apostrophe after it is called prime. So notice here, whenever point A is on line K, when we reflect point A over, A prime and A end up both being in the exact same spot, which is right there. Now, when I reflect this point A over line K, A prime ends up being, again, the same distance, and this is perpendicular, making K the perpendicular bisector of line segment A prime. Now, here we're going to see another example of that, but done out with 3 different points. Now, the way that we reflect an entire shape is by reflecting the individual points. So basically, I take point A, and I reflect it to A prime. I take point B, reflect to B prime, C to C prime, and then I come in and I draw all three of my line segments connecting those 3 points, and that's how I'm going to go about drawing or reflecting an actual shape. It's much easier to reflect the individual points and then connect them with the line segments, as opposed to trying to reflect the shape as a whole. And what I mean by that is if I had this triangle, I cannot think through this whole reflection thing because I end up drawing it funky every time. But when you're actually, if you go through and reflect the points, you'll see me do that in a second, it's much easier to reflect points than the entire shape. Another example of that, again, just make sure you reflect every single point, make sure it's perpendicular. So, Draw the reflected image about the reflection line M. Okay, easiest one. First off, K prime is going to be the exact same as K because it was directly on the line. Now, here's what I'm going to do with my ruler. I'm going to come in to get an approximate 90-degree angle here, and then in real life I would do this with a compass, but since OneNote doesn't have a compass tool, I'm going to count my lines as I go. So there's 1, 2, and 6/8. So then I'm going 1, 2, and 6/8 approximately. This is not perfect. There is my point H prime. Okay, sorry about that. Had to help my son with something. Now let's do the exact same thing here with J. And you can see on this one, J is almost exactly one of those units. So I'm going to go one of those units away there. And then I've got my point J prime. And now I'm going to go in and draw my line segments. And there we have an, go ahead and erase that so you can see it better. There we go. I think they look pretty good. Triangle reflected in line M, and we've got triangle J prime, K prime, H prime. Okay, 2, we're going to do the exact same thing. Only difference here is that we do not have one directly on the line. Again, I'm going to come in here at approximately a right angle. Then as I'm doing point W here, looks like I've got about a half. It's about a half more. There's W prime. For Y, there's 1, 2, 3, 1, 2, 3. Y prime. Now X prime looks like I'm about 1 and a little over a half. There's my, I wish this thing was actually numbered. 1.5, 1.5. That's maybe good enough about right there. Sorry guys, this is one of those places where I'm a little bit limited by the technology. I've got 1 1/4, so there's a quarter, and then 1. So there is Z prime. And now I come in and draw my lines. Okay, there we go. There's my reflected W prime, X prime, Y prime, and Z prime. Now, what we're going to be doing with all of our transformations is using what's called coordinate mapping. Now, it's going to be using this format, and it's always going to be pre-image transforms to image. And so we also say it sometimes goes to there. Now what will end up happening is we'll do things like saying x, y goes to x plus 2 and y minus 3. What this means is we take our original x coordinate and add 2 to it. Take our original y coordinate and subtract 3 from it. So those will give us different rules for how we're going to be transforming our points. And you'll see what that looks like as we go through and do some of these. Let's see, that slide was probably a little bit out of place, but here we go. We're going to reflect over the line x equals -1. Now, x equals -1 is a vertical line at -1, so I'm going to go ahead and draw that. Now, horizontal and vertical lines are very easy to reflect over, because especially when we have all of our grid lines drawn. Because here I can see that G and G prime are the exact same point. Then F, I can go ahead and just count that distance, 1, 2. We're going to go 1, 2 again to get F prime. Then H is 1 away, so we go 1 away again and get H prime. Then I come in and grab my straight edge to draw the actual shape. And this is what I meant earlier by it's easier to translate or to reflect the points and then draw the lines as opposed to trying to reflect the entire shape or the lines as a whole. So there we go. G prime, F prime, and H prime. Much easier when you've got a coordinate grid. Now let's reflect over the line y equals 1. That's a horizontal line at 1. Draw my line of reflection in. And now H is 1, 2, 3 away. So we're going to go 1, 2, 3 above, and that's where H prime sits. G is 1, 2, 3 above, so I'm going to go 1, 2, 3 below. That's G prime. F is 1, 2, 3, 4 above, so we're going to go 1, 2, 3, 4 below, and there's F prime. Now let's go ahead and draw our segments. There we go. All right, now reflections over lines on the graph are not that difficult to do. You just saw me do ones over horizontal and vertical lines. Now, when we're reflecting in the x-axis, realize that all we're doing is using the axis as the point of symmetry. So since this distance right here is y, whenever I go to reflect it, it's going to end up getting a negative y. So our coordinates are x, y, and then this gets transformed to x negative y. That's why our mapping rule here is going to say that xy goes to x negative y. This is just saying take your original y and multiply it by a negative 1. When we're reflecting in the y-axis, we do the exact same thing. Here, this distance is x, this distance is negative x. Now, of course, that negative, since it's in the on the negative side, the negative times a negative becomes a positive over here. So that's all we're doing is multiplying by negative 1, and we got the exact same concept down here. Now, when we reflect over the line y equals x, things get a little bit hairy, because what ends up happening is that we have to take this straight line distance here, straight line across, and what ends up happening is the coordinates get swapped. Now, one easy way of doing this, if you're trying to count it, is to take this distance horizontal over to the line y equals x, and then take that and reflect it down. That will get you to the exact same place. So what's happening here is we take our x distance and then x again. That's essentially why those two coordinates are being swapped there. Now, we're going to be reflecting ABCD in the x-axis, which means we're using our x-axis as the line of reflection. So all we're going to do, well, we could do it the same we did earlier with the just by translating and counting points here, or counting distances to the line, but I'm going to do it using our mapping rule, which was xy transforms to x negative y. So A, which is at point 1, 1, is going to transform to x stays the same, which is 1, and then negative y means multiplied by negative 1, so that's negative 1. So we're at 1, negative 1. There's A prime. B, which was at point 3, 2, will transform to 3, negative 2. So 3, negative 2, there is B prime. C, which is at point 4, negative 1, will transform to 4, positive 1, because negative 1 times a negative becomes a positive. So we've got 4, 1. Oh, I should have done that with orange. and there is C prime. And then D, which is at 2, -3, transforms to +3. 2, +3, there is my D prime. And then I just go in and draw all of my segments. And I've got the reflected image. There we go. Example 6. Let's go ahead and do the exact same idea. We're going to have points A, B, C, and D, which are at 1, 1, 3, 2, 4, -1, and at 2, -3. We're going to perform the transformation on all those. And we're going to be reflecting in the y-axis. So my rule for this is xy transforms to -xy. So we're going to basically just be taking the negative of the x-coordinate. So that becomes a -1, 1, -3, 2, -4, -1, and -2, -3. So -1, 1 is A prime, -1, 2, 3, 2 is B prime, C prime is -1, 2, 3, 4, -1, and D prime is -2, -3. -2, 1, 2, 3 is D prime. And there we go. Now, what I think is amazing about this is that entire time that I was doing this, I mean, I don't know what y'all are doing as you're copying and watching the video and listening, but I did not look at this over here one bit the entire time I was doing that. I was focusing solely on all of these things. And so just by following the rules, and then by plotting the points, I get a perfectly reflected image. It's amazing to me when that symmetry just works out so perfectly. Also, it might seem at this point like it's a little bit kind of ridiculous to be doing it this way, because it honestly is a little bit easier just to count over 1 and then go over 1 again. We're practicing a skill right now. Trust me, when we get to rotations, you're going to really want to have practiced this skill, because rotations are not quite as easy to do you can't do it by sight. You need to do it by coordinate manipulation. Okay, so let's do this onto the line y equals x. Now remember, that is yx, I'm sorry, not yx, xy transforms to yx. So let's go A, B, C, and D, which are at 1, 1, 3, 2, 4, -1, and 2, -3. Go ahead and get all of those set up for us. Now, 1, 1. What we're going to do is we're going to take our x and y coordinates and swap them. Well, 1 and 1 just stays 1 and 1. 3 and 2, we're going to switch them. That becomes 2 and 3. This becomes -1, 4, and this becomes -3, 2. Now, let's plot our points. 1, 1 becomes A prime. 2, 3, 1, 2, 1, 2, 3 is B prime. C is -1, 1, 2, 3, 4 is C prime. And the -1, 2, 3, +2 is D prime. Draw our line. Draw our line. Oops, I keep on grabbing the paper instead of the ruler. Draw the line there. And then draw the line there. Now, at first glance, it's not as easy to see this one actually is the real reflection of it. It also is kind of interesting or curious why A prime ended up being the exact same coordinates as A. Well, remember, this is the line y equals x. That's the line that has a slope of 0, a y-intercept of 0 and a slope of 1. And so this is our reflection line. So whenever I look at that now that I draw that in there, I can see exactly why A and A prime had to be the exact same point, because they're directly on the line of reflection. Then, or what I told you earlier about doing these by counting, I could count over from B to the line of 1, and then take the 90-degree angle and go up 1, and then there is where B prime is. For C, I could go over 1, 2, 3, 4, 5, and then up 1, 2, 3, 4, 5. And that's where C prime is going to be. Either one of those situations works. Again, it's good to get used to doing it from our coordinates as opposed to relying on counting, because we can't always do that if the image is too large. Okay, that takes care of it for translation or for reflections. Now let's do translations. Translations are actually quite a bit easier than any of the other ones we're going to be doing. All we're doing is essentially just taking a shape and shifting it. Here we shifted it to the left. Here we shifted it to the right. No big deal on those. Whenever let's use this in a word problem first. We go 4 units to the left and 5 units up. Let's go ahead and graph our points first. TU is -3, -6, and I also noticed that these are going by 2s. So -3, 8 is going to be here. There's point T. -6, 3 is here for U. W is 0, 3. And then V is 3, 0. I had to have done that wrong. -3, -8. I didn't see that negative up there. -3, -8. There we go. T should be right there. Okay, now what we're going to do to shift this 4 units left and 5 units up, we're just going to count that on every single one. We're going to go left 4 and then up 2, 4, 5. There's W prime. 4, 2, 4, 5. There's U prime. Over 2, 4, up 2, 4, 5. There's T prime. And then over 2, 4, up 2, 4, 5. There is V prime. And then draw our shape, draw our segments, and we are good to go. So there we go. Our shape's been translated up just by shifting all of the individual points. All right. Now, I'm honestly going to skip number 9 because I think you get the point on that. Same idea. I'm not going to worry about doing these over and over again. You guys understand how to move those guys around. One of the things I do want to cover on these, though, instead of actually doing each of those, is just to show you how the I guess I can do it all on this one, is to show you how the mapping rule works. XY translates to, so on this one we're going 4 units left, Well, left is a x concept, and it's a negative value. So we're going to be taking our x value and subtracting 4. To go 5 units up, we're going to get y plus 5. So my rule here is xy transforms to x minus 4, y plus 5. On this one, we would get xy transforms to, now if we're going to be translating 1 unit to the right, that's an x plus 1, and 2 units down is y minus 2. And then here, xy, let's see, we're going 3 units left, so that's x minus 3. Down 2 units is y minus 2. Again, I trust you guys could fit that in there if you needed to. And then find the translation that moves the soccer ball on the coordinate plane to the given places. To go from ball 1 to ball 2, well, it looks like we're going right 1 and then down 1, 2, 3. So that's xy moves to x plus 1, y minus 3. To go from ball 2 to ball 3, looks like we're going 1, 2, 3 over, and then down 2. So that's xy transforms to x plus 3, y minus 2. To go from 2 to 4, go ahead and erase those. So I'm going over 1, 2, 3, 4, 5. And then down 1, 2, 3, 4. So that is xy goes to x plus 5, y minus 4. And then to go from ball 3 to ball 1, looks like I'm going to be traveling to the left by 1, 2, 3, 4. Then up by 1, 2, 3, 4, 5. So that is xy goes to x minus 4 and then y plus 5. Now, I want to go ahead and mention something else that's not directly on here, but something I want you guys to see because it gets used in your physics classes when you get there, and that is called a vector. Now, a vector is just essentially keeping track of the way that things move in three-dimensional space. You can have two-dimensional or three-dimensional vectors. We're only going to mess with two-dimensional vectors for now. Get on to your physics classes. I'll let y'all throw in the z-coordinate and take care of that thing. Now, the way that we write vectors is same idea as all these translations. Actually, all they are is just another way of writing translations. But instead of writing this, because this is a little bit of cumbersome notation, I'm going to write it with angle braces. Now, this angle braces means move. And the first coordinate is going to be a x translation. The second coordinate is going to be a y translation. So if I was to take this guy and write it as a vector, all I would do is write 1, -3. Written this way, this means take a point, take an object, move it 1 unit to the right and 3 units down. If I was to do that for b over there, I would just write 3, -2. And this means everything that's in there. For number 3, I would write it 5, -4. And for part D, I would write it as -4, 5. Okay? This one is the kind of pure mathematical way of writing it. The vector notation is the more the scientific way of writing it. Either way, it works. You'll see me interchange between those as we go further on in the unit. But that's it for now. I hope that was easy enough to swallow. We're going to be moving on with our other transformations later on in the unit and get to work on your homework in class. And as always, stay patriotic.